Okay, trig probably involves a substitution because we have two different trig functions, and if you consult your trig derivatives, you're not going to find any derivative that directly gives sine and cosine, especially not with this combination of powers. But here is a way that we can make it work. We can say u is sine x. Then du is the derivative of sine is cosine x, and at the end pops out dx. And you can see this is going to work nicely because cosine x dx is right there. All this together is going to get rolled up into our du, and then we're going to have u to the third. So this integral becomes u to the third power du. And suddenly that's no big deal. Its integral is just increase the power by 1, divide by the power, throw in a c, and then revert your variables. Where u used to be, we're going to say sine x instead. So here we get 1/4 sine to the 4th x. Or if you wanted here, you could say sine x all to the 4th power. It means the same thing. And plus c. No big deal. Did you consider at all using cosine as your u? Because that's not a terrible idea. I mean, it's not going to work, but it wasn't a bad thing to think about, and I'll show you what happens if you try it. Let's do this again and say u equals cosine x. And let's see what happens if we try to make that fly. Du is negative sine x dx. That's got a negative sign in it, which we'd have to deal with, but we could say negative du equals sine x dx. That's no big deal. Now, when we try to do the integral with this substitution, here's what ends up happening. Cosine x is u. We get a u there. Dx, we'd have to replace with what? We'd have to divide both sides of this by sine x and get negative du over sine x equals dx. So the dx part gets replaced with negative, I'll put that out front, du over sine x. This is a little hairier than this version, but nothing too impossible so far. But here's where it gets bad. We need sine cubed. We can't use this. The only way we can come up with sines here is to put du inside this function, and doing something like du to the third power is not allowed. Your integral must contain a du, but it must only contain it once, and it cannot be inside a function of any kind. So you cannot, at any point in a substitution, and we will never do this either, you cannot have root du, you cannot have sine du, you cannot have 1 over du, or anything like that. You cannot have any function of your du. So if you ever end up in a situation where you have to do that, like, oh, I'm going to have to cube my du, that means your substitution's no good. Back up and try something else. You can have a du sitting on the tail end, and in fact you always will, but it cannot be, you cannot operate on it. So if you get a substitution that's telling you to do that, it means bail out, try something new.